Today we're going to talk about lesson 4-2, standard form of a quadratic function. So we already talked about several of these things yesterday. So we're just going to fill in some things. So any function that can be written in the form of ax squared plus bx plus c is said to be in standard form. So the properties of quadratics, we've talked about quite a few of these. The graph is known as a parabola, so you're supposed to know what that means. So that means that it's going to open this way or this way, so it looks like a U. If a is greater than 0, meaning that it is a positive value, the parabola opens up. If a is less than 0, meaning a negative value, the parabola opens down. The axis of symmetry is the line, and we get x equals the opposite of b over 2a. Again, we get that from the standard form here, the opposite of b over 2 times a. The x-coordinate of the vertex, remember, the axis of symmetry goes through the vertex, and so the x-coordinate of the vertex is where we get the axis of symmetry. So that's the same thing. X equals the opposite of b over 2a. The y value of the vertex, you basically have to take the x value of the vertex and plug it in to the function. So technically in math terms, it looks like f of the opposite of b over 2a, because that's the x value of the vertex, plugged into the function. So mathematically, that's how we write it. The y-intercept is great, because think about this. The x value on the y-axis is always 0. So if I plug 0 in here, 0 squared is 0, times a is 0. 0 times b is 0. 0 plus 0 is 0. Plus c is c. So whatever the constant is, that's your y-intercept. So, and your y-intercept, as I said, the x value is always 0. So the y-intercept is an ordered pair and is always written 0, comma, whatever c is. Then it says use a calculator to find the features. We do not need a stinking calculator to find the features. Okay? We can find the vertex by using, you could use a calculator, but there's a non-calc portion and a calc portion on this test, so we're going to learn how not to. So you first have to find the x value of the vertex. So I'm going to use do the x value of the vertex. So x sub v means x value of vertex. It equals the opposite of b over 2a. Well, we were given the equation up above. So up above, a is equal to -3, b is equal to -6, and c is equal to 8. So I'm going to plug the values I need into here. Notice that I am only putting parentheses around the variable and not its sign or number. So my b is -6, and my a is -3. So I end up with 6 over -6, which is -1. So then the y value of the vertex, you're then going to take the original equation that they gave you in standard form, and wherever there's an x, you're going to replace it with the x value you just came up with. So this value goes in here and in here. So -1 and -1. So we get y equals -1 squared is 1 times -3 is -3. -6 times -1 is +6 plus 8. 6 plus 8 is 14 minus the 3 is 11. So our vertex is -1, 11. Now from that, remember from our lesson yesterday, you get two things from the vertex. The axis of symmetry is the x value, so x equals -1. Now remember from what we just discussed above, since a is negative, our parabola opens down. since our parabola opens down, we have a maximum because the vertex is at the top of the parabola, and that would be the the y value of the vertex. Then I don't even have to graph this to find domain and range. So we know that domain, they didn't ask for it, but domain is 100% of the time for these, negative infinity to positive infinity. Well, if my maximum value is range, or my range is 11, that means that on here I have my smallest range to my largest range. Well, if this is my maximum, the 11 has to go where the largest range goes. So my 11 is going to go here. And remember, if my parabola opens down like this, my smallest range is down here at negative infinity until I hit this highest range value of 11. So my smallest range value is going to be negative infinity, parentheses. So I have brackets here, parentheses around the infinity. And that's it. You really don't need a table of values. Now, if I were going to graph this, I would put my vertex in the middle of my table of values. So I would put it here, negative 1 here, and 11 here. Then I would choose values smaller than negative 1 and larger than negative 1. So like smaller than negative 1 would go negative 2, negative 3, negative 4. Larger would be 0, 1, and 2. And you could plug those into the function and find the y value and easily graph this. But we're not going to right now. All right, so here I have given you, clearly, I didn't mean to do that. So here I've given you the procedures, make it a smidgy bit smaller, for graphing. So we have already kind of talked about what we're going to do. So you have to identify A, B, and C from the equation you're given. Determine the shape. That means, does it open up or down? Find the axis of symmetry and sketch. Well, in order to do that, you have to find the vertex first. Once you find the vertex, you plot that. Plot in your axis of symmetry. It gives you a visual line of where you're going to reflect your points. So you've got the x and y vertex plotted. We just talked about how to find that. And then you will find, you're going to plot your y-intercept. Remember that y-intercept is 0c. Once you plot the y-intercept, as long as it is not the vertex, you can find the reflected point to that y-intercept. Look at how far the y-intercept is from the axis of symmetry and go to the other side and plot an equivalent point, and that'll give you shape to your graph. However, I want 5 points plotted, not 3, as long as you can fit them on your graph. So here we go. Let's look at this one, shall we? Where's my graph? Oh my goodness, it's so tiny. Okay. So first things first, I need to find my vertex. So number 1, vertex. So the x value of the vertex is equal to the opposite of b over 2a. So I'm going to list out a, b, and c. So a is equal to the coefficient from the x term, the x squared term is 1. B is equal to -4, and C is equal to 1. Since A is positive, I know that this opens up. Because it opens up, my vertex is at the bottom, and so I have a minimum. I'm just going to throw those in there. So let's plug in. So put in a -4 and a 1. And I get +4 over 2, which is 2. So the next thing is to plug it into the function. Wherever there's an x, you have to put our value of 2. So that 2 that we just got goes here and here. And then that gives me 4 minus 8 plus 1. The 4 and the 1 is 5. 5 and a -8 is -3. So now I know that my vertex is, so my vertex is 2, -3. So that's going to be the first point that I plot, and then I'll put in my axis of symmetry. Let me move this over a smidge. There we go. Okay. So let's put in 2, -3. Wow. They gave us just the bare minimum, huh? Good thing the graph opens up. Then I'm going to put in that axis of symmetry because it's a visual line of symmetry. Now I know that my y-intercept, so step 2 is going to be the y-intercept. So step 2, y-intercept, because that's the second point I plot. Remember 0, C. So since C is 1, it's 0, 1. So I'm going to plot a point on the y-axis at 1. There it is. So this point is 2 units from the axis of symmetry, so I want to go 2 units on the other side. There's the reflected point. So the reflected point is 4, 1. And then you need to choose one more point that's easy to plug in, because I want 5 points on that graph. So step 3 is another point. So easy values to plug in are like 0 or 1 or 2. Well, 0 is already used up for the y-intercept. So my next favorite point is 1. So I'm going to take y, and I'm going to plug in for x, 1. 1 and 1. And so that gives me 1 minus 4 plus 1. Well, 1 and 1 is 2, and a -4 is -2. So when x was 1, y was -2. So that's my other point, 1, -2, right here. Notice that that point is 1 unit from the axis of symmetry, so you want to go 1 unit on the other side. There, right there is the reflected point. So now we can connect those points, and it better make a nice curvy U. All right, so pause the video, and I want you to do this next one. Did we answer all the questions? Yeah, pretty much. Okay, so then I want you to do the next one on your own. All right, so hopefully you pause the video. I'm going to do my work down here at the bottom. So first I'm going to find my vertex, but in order to find that, I need to know A, B, and C. So A is equal to -2, B is equal to 2, and C is equal to -5. So I already know my y-intercept is, that's a -5, is 0, -5. So let's find the vertex. Really, that's step 1. So the vertex, the x value of the vertex is equal to the opposite of B over 2A. So B is 2, and A is -2. So I end up with -2 over -4. Oh, isn't this fun? We get a value that is +1/2. So this should be your only fractional point. If you choose wisely, this is your only fractional point. So then the y value of the vertex, I'm going to plug that in. Don't be afraid to plug that in. So I'm going to put that 1/2 in here and in here. So remember, you cannot multiply the -2 to the 1/2 first and then square it. So you can't cancel these. You have to square first and then multiply by -2. So 1/2 squared is 1/4 times the -2 is -2/4, and that reduces to -1/2. Then the 2's here are going to cancel, and you get a +1 and a -5. So the +1 and the -5 are a -4. A -4 and a -1/2 is -4 1/2. So then your vertex is 1/2 -4 1/2. So let's plot that. You're right here in the middle of that square. That's 1/2 negative 4.5. I want to make it a little bit bigger. There we go. Then you got to plot in your axis of symmetry, which remember that is x equals the x value of the vertex, which is 1/2. And put in your y-intercept, which we already found was 0, negative 5. Oh, and we didn't talk about this, but doesn't this open down? You want to know what direction it opens because a is negative. So it makes sense that my y-intercept is 0, negative 5. So here's where you have to be a little bit careful. This is 1/2 unit from the axis of symmetry, so 1/2 unit on the other side is right there. So that's my reflected point. So the reflected point is at 1, negative 5. And then I need one more point. So since 0 and 1 are already used up, let's use 2. So then my second point, y equals negative 2 squared plus 2 minus 5. So I'm going to put in positive 2. So positive 2 times positive 2 is 4, times the negative 2 is negative 8. 2 times 2 is 4, minus the 5. So the negative 8 and the negative 5 are negative 13, plus 4 is negative 9. So I have an ordered pair that is 2, negative 9. So I'm going to plot that. Now this is 1.5 units. So I have to go 1/2 and 1 on the other side. So I'm here at negative 1, negative 9. And now I have enough of a problem where I can sketch it. There we go. Okay, so now we're going to actually put this into vertex form. So remember, for vertex form is y equals a times x minus h squared plus k. So I need the vertex, which is h and k, and a. Well, the a here, the a here is the same as the a here. So the a in standard form and the a in vertex form are the same and identical, so that's nice. So remember, yesterday in the previous lesson, we had to have the vertex and another point so that we could find a. Well, we just need to find the vertex, which we know how to do, and we already have a, so once I find the vertex, I don't need another point because I have a. So find your vertex. So for this one, I've got a equals 2, b equals negative 8, and c equals negative 3. So x value of the vertex, so this is step 1, is equal to the opposite of b over 2a. The opposite of b over 2a. So b is negative 8 and a is 2. 8 over 4, which is 2. So then the y value of the vertex we're going to plug in. So I'm going to take that 2 and put it in wherever the x was. Remember that you have to square this before you multiply by this. So 2 squared is 4, times 2 is 8. Negative 8 times 2 is negative 16, and a negative 3. So 8 and negative 16 is a negative 8, and a negative 3 is negative 11. So the vertex is 2, negative 11. So what that gives me is my h and my k. And then I know that my a is 2. So step 2, use your form. So I don't plug in for y. I know that my a is 2 from previously, and then x, the minus h means the opposite of the h here. So if the h here is 2, I'm going to put a minus 2 here. Don't forget to square it. And then the k is exactly what we see here. Since the k is minus 11, we have to put a minus 11 here. And then this is the final answer that they are looking for. So then you need to pause the video and do example 5 and then restart it. Okay, so I'm going to make this bigger, straighten it out. Here we go. So I know that A is equal to -1, B is equal to 4, and C is equal to -5. So my vertex, x value, the opposite of B over 2A, so my B is 4 and my A is -1. So I get -4 over -2, which is +2. The y value of my vertex, oops. Let's try that again. The y value is negative. Now that negative should not be in parentheses. It is on the outside of the parentheses. So that 2 that we just got is going in here. So when you square this 2, the negative's not squared. So 2 squared is 4 times the negative. That has to be a -4. 4 times 2 is 8 minus the 5. So a -4 and -5 is -9, and an 8 is -1. So your vertex is 2, -1, which gives us our h and our k. And then we already know that a is -1, so then step 2 is to write your equation. So y equals, our a is -1, so you could just put a negative there instead of a -1. The opposite of h is -2, and the exact thing as k is -1. And so there's your answer. Okay, so let's look at, no, not that. Let's erase that. Let's look at the word problem below. So I'm going to make it a little bit smaller. So when you're looking at word problems in this section, you essentially want to figure out what part of the parabola are they wanting me to find. So this says a model for the performance of a stock is P equals -3d squared plus 50d. So this is our quadratic that we're looking at. And note that we are missing the constant. So if you're missing the constant, then your C is going to equal 0, just in case you need that for future reference. Then it also goes on to say where D represents the days of trading and P is the price per share. So depending upon a number of days trading will influence the price of that share. So the question is, what is the maximum price per share of the stock? That's what we're trying to find, the maximum price per share. Key emphasis on this word maximum. So we know that this is a quadratic because it's squared. What part of the quadratic is a maximum? Isn't that the vertex? Correct. So I need to find the vertex. So really it's no different than what we've done before. We're just going to find the vertex, and specifically what part of the vertex? We want to know the k, or the y value of the vertex. So to do that, I have to find the x value of the vertex. So let's list out A, B, and C. So A is equal to -3, B is equal to 50. So I'm going to put in 50 for B and -3 for A. So that gives me -50 over -6, which is reduce it. Your negatives turn into a positive. Divide them both by 2. You get 25 over 3. So we're going to find the y value of the vertex. So I'm going to put that 25 over 3 here and 25 over 3 here. Now don't get excited and cross these 3's out because you have to square the 25 first. So you get -3 over 1 times 25 squared is 625. 3 squared is 9 plus 50 over 1. 25 times 50 is 1250. 1 times 3 is 3. So then I can reduce this. 3 divides into -3 -1 times and into 9 3 times. So I end up with -625 over 3 plus 1250 over 3. They have the same denominator, so I can combine them, and that will give me 625 over 3. So when you divide that, y is going to, because remember, y is our price, and so price is in money. So money isn't normally as a fraction. So I'm going to divide 625 by 3, and I get approximately $208.33. So since that's the y value of my vertex, I don't know why I put a 1 here, that just need really one step, we can write a therefore statement. So therefore, the maximum price per share of stock is about $208.33. Now our last problem is a fun doozy. Whoops, I keep doing that today. Okay, so let's read the problem first, and I'm going to enlarge this picture so that we can have more room and just kind of see the picture and work with it. So it says, the New River Gorge Bridge in West Virginia is the world's largest steel single arch bridge. Well, that's interesting, but okay. You can model the arch with a function here. Now this is a quadratic because the x is being squared. So that's something important that I'm going to highlight. Right? Then I'm looking for parts that I need to know. So continue reading. So x and y are measured in feet. Approximately how high above the river is the bridge and how long is the bridge? So we have 2 questions to answer. This is the height that the bridge is above the river, because here's the river down here. So I need to find this whole distance here, and then I need to find this distance from here to here. Okay, so what would be handy is, well, I know that this distance from here to here is 516 because they told me that, so I need to know this distance. You don't have a coordinate system on here. You don't know where your origin is, so why can't you make your origin wherever you want to? So this would be the smartest place to put your origin, right here. So I'm going to enlarge this picture so that we can see it and work with it. You have your equation in front of you, and then we're just going to work from here. So I'm going to put on here, right here, can you see that? Yeah, right there's my origin. So that's my 0, 0. So this is my parabola going from here to here, right? So that means my y-intercept is going to be my vertex. So let's go ahead and find our y-intercepts. Well, it might not be our vertex. Let's go ahead, let's play with it for a minute, because it clearly depends upon our equation. So let's run it through. So we have an equation which is y equals negative, and I've got 3 zeros, and 498. Clearly you're going to need a calculator for this. X squared, and then plus so I think we're going to have to actually rethink this. This actually may not end up being our origin, because this equation here knows where the origin is. I just don't know where it is on the picture. So let's wait to see what the x value of the vertex is, because the x value of the vertex is going to move us, you know, whatever this point is, that's our x value. And hopefully it's positive, because then that means that somewhere over here is a 0 to there. So perhaps we can think of it this way, that the end of the bridge is 0, 0, and over here is half the way to the bridge, and over here is the other half. So let's just see how the x value of the vertex turns out. So step 1, find your vertex. So our b is 0.847 over 2 times, and our a is that lovely long negative and then if you put that through your calculator, you're going to get approximately, I'm going to round this to the nearest foot, so it's approximately 850 feet. So that is going to be our distance from, now I don't know why they're just showing this, because the question says how long is the bridge? Well, the bridge goes from here over to here. So one of the assumptions we're going to have to make is that this is directly in the middle, because this arch support here, let's hope it's in the middle. It's hard to tell. So we're going to make that assumption. So let's assume that. But over here is going to be our 0, 0. So if this is 850 feet, this is 0 feet. Measuring, I hit 850 feet. Okay? So let's assume our 0, 0 is over here. Then the y value, well, our 0, 0 can't be over here, but this, our 0, 0 is going to be down here. That makes more sense. Our 0, 0 is here, because this would be our x value, and then go up to your y value. There we go. So 0, 0 is going to end up over here, kind of underground. Let's go ahead and throw that in there. And you'll see y here. So if I went all the way down here, technically this is our 0, 0. They're trying to make it here because that's the end of the parabola. And I guess if you want to think about it, there's no 0 here, so our y-intercept should be at 0, 0. So I guess they're only wanting the length from here to here. What a stupid question. Wouldn't you consider the length from here to here? Well, that's why they gave us this picture. All right, now that I've thought my way through it. But y'all agree that they're a little bit wrong. So I'm guessing that that equation isn't exactly accurate, because if our y-intercept here, the c is 0, that means that our x value is 0, our y value is 0. So that is where 0, 0 is. Now I've reasoned my way to that one. All right, that's 0, 0. Okay, so this is my vertex, and we have now figured out that this is 850, and we're going to find out the other part. All right, so then step 2, or part of step 1, we still have to finish the y value, is and then we're going to put that 850 in here and square it. You run that through the calculator, and you're going to get approximately 360 feet. So this is 360 feet. So what that means is from 0, 0, I traveled to the right 850, and I traveled up 360 feet to plot that point. So that must mean that the distance here is 360 feet from here to here. And the distance from here to here is 850 feet, which is the distance from here to here. So this is 850 feet here, which means that this is 850 feet here. Because the assumption is that this is a mirror image of this. So we now have the ability to answer our questions. So step 2, the height above the support which means that 360 distance, the height above the support is 360 feet. Okay, so then step 3, the height above water is the 516 feet plus that 360 feet. So remember, here's the water. From here to here is 516, and from here to here is 360. So we're just adding those together. And so that equals a total of 876 feet. I would write that in a sentence if I were you. And then step 4, the length of the bridge even though I disagree because I think the bridge is longer, but again, I'm not queen of the world. So we're going to take the first 850 and add to that the second 850. So we already discussed that we're going from here to here. And that's going to equal, moving this up, a total of 1,700 feet. Wasn't that fun? Now, if you have any questions on your homework, don't hesitate to ask.